Hi, this is Jean-Francois with you to discuss the standard normal distribution. A variable that obeys a standard normal distribution can be labeled using Z follows a normal law with parameters 0 and 1. We'll explain later on where the 0 and the 1 come from. Letter Z from now on will be strictly used to label a standard normal distribution. When Z follows a normal distribution with parameters 0 and 1, then Z is a continuous random variable and it has the following properties. Its support, or its domain, are all real numbers. The density function for variable Z can be expressed as 1 over 2 pi rooted e to the minus z over 2. F of z is strictly positive and is symmetric about the vertical axis z equals 0. Furthermore, f of z has its maximum value at z equals 0. F of z has inflection points as z equals plus or minus 1. And it has horizontal asymptotes at 0 at both extremities. E of z will be 0, and the standard deviation for z will be 1. Those are the parameters that are expressed in the normal laws labeling, so 0 and 1. To summarize, f of z has the appearance of a bell curve. As you can see, this particular bell curve is centered around z equals 0 and converges towards the y-axis at the extremities. As is the case for all density functions, the area under the curve can be represented as probability. So the probability that z will take on values between a and b can be obtained from the definite integral with bounds a and b. Also, the integral over the entire support r should add up to 1. Now here's our main problem. F of z does not have a known antiderivative. So it will be impossible for us to compute this definite integral ourselves. So what will we do? In the old days, we could use tables where the area left of a certain z value was provided. Today, with some more sophisticated tools, we could use, for instance, Excel, which will give us the probability for specific values of z and those that precede it. Like most cumulative properties, the area is calculated left of a certain z value. If z follows a normal distribution, then we can calculate the following probability as an example. P of z being left or equal to minus 1. The result we will get is 15.87%, as obtained from Excel. Notice how, in the Excel function, loi normale standard, or in the English version, standard norm dist, you will have to provide the z value that delimits the area on the right extremity, and therefore you're calculating area left of this right bound. If we wish to obtain the probability that z will be greater than 1.5, then we will have to reverse the situation and find how much is left of 1.5 and go by exclusion. Once again, Excel can provide the value of the area left of 1.5 and we can calculate the difference. We could also use symmetry. Because of how the standard normal law appears, any area to the right of 1.5 is equal to the area left of minus 1.5. Then, Excel can be used to calculate the value for this delimiting value. The probability that z will take on values between two bounds, -1 and 1.5, for instance, will mean finding the entire area left of 1.5 and then cutting off the portion that we do not want, which is left of -1. In other words, 2 calculations will have to be done and the difference will be obtained later on. As usual, Excel provides values for these areas. Now, going backwards, if we know that Z obeys a standard normal law, is it possible to find the value left of which 10% of the area is found? Since we are going in the reverse direction that we were in previous examples, actually you will have to use from Excel the inverse function, loi normale standard inverse, or norm dist inverse. Provide the area or the amount or the proportion of the area you want in the probability window, and Excel will give you the corresponding Z value. If you wish to find the value right of which 35% of the area is found, once again, you will have to convert this into an amount of area left of a certain bound. So, left of B should contain 65% of the area, and the inverse standard law will give you the value for B corresponding to this probability. Finally, what if we wish to have a symmetric interval where 40% of the area is located? By deduction, we can figure that 30% of the area will have to be left of -C, or 70% of the area will be to the left of +C. Going with one or the other can help you find the value of C that will be necessary. It is common notation to use Z alpha and -Z alpha to represent the values that exclude an area corresponding to alpha at either extremity of f of z. For instance, -z 10% is the value of z that excludes the leftmost 10% values of the distribution. We can use Excel to find the value of this corresponding number. Z 5%, because it's a positive entry, will give you the value of z that excludes the rightmost 5% values of the distribution. Once again, Excel will tell you that Z 5% is 1.645. Now observe how in Excel I've entered 95% for the probability, because 5% being excluded at the right extremity means 95% of the area is left of Z